Hello explorers and welcome to another video. Today I'm gonna go through how to create a simple web server REST client. And in this video I will go through an implementation of from the Sun guys in a pure Java sense, how to build a web server. I also will go through my socket solution, which solved an issue I had with the response headers not being formatted correctly. And I will also look into how to save data in the backend, how to create specific endpoints, and so on to structure my code in order to handle a REST call from different endpoints and also from different methods. So let's start from inside out and look at the thing that actually has all the data. So I have created a notes repository, and it actually has no connection to any database or any data storage at all. So this is totally in-memory data storage, but for this kind of use case, it's not that important. So here we see that I have a JSON array, and this holds all my notes, and this is also a singleton, so I will only have one instance of this class at any time. The only way to create one is through this static method, because the constructor for this class is private. And in the construction, I create one message, so I have something on screen when I load this up, so I see that it's actually working. And then I have a very simple function to look up one key and get that note. I have a simple function to add a note to my repository. I have some function to update a note and get all the notes, so I get the full array back, and also delete a note. So these are quite simple standard functions, and you can look at those in the Git repository if you like. Then I have this endpoint function here, and this is to handle one single endpoint's routing information. So I have some abstract method here that I will implement in the different collection or item methods or the classes. And it also has a path param, so these are all the parameters that comes in the path, or perhaps query parameters in the future. And then we have a response code, so I can check what kind of response got back. And I also have this public method to get the response code. And then I only have one simple function here to handle the request. It takes the method and the body, it parses the body, gets an object, and that could be either an array or an object, a JSON object. I didn't want to be too specific what kind of objects I was working with here, because I thought that you might want to do a post on a collection to change sort order or something like that, which you can do in REST sometimes. And then I just check the method if it's a get, post, put, patch, or delete, and I will call those methods pretty much. And when I get the response, I will check if it's null, I will return nothing. If it's a string, I will return that. If it's any JSON object or JSON array, I will return those. And if I can't really figure out what it is, I will return an empty string as well. I can set the response code from other function. This could be actually protected, because I think this will only be used by anything that implements this class. I can add path params and get path params, so those are done by other methods. At least add path params will be done from the outside, and I have a function to check if the path param is available. So this is an endpoint. If we look at the collections implementation here, it's pretty simple. If I have a get on a collection, so I will get all the objects of a collection, and that's if you are pointing your query to notes with no ID. So you will want to get all the nodes. And this will all just return the full nodes repository, get all nodes, and return code 200. And in the post, I will check if it's a JSON object that is posted, and if not, it's not a valid JSON object. I will return 500. And if I don't have any text in my JSON object, I will also return a 500 with no text as an error message. And lastly, I will add the node to my repository and return 201. So this is what's done when everything is okay. Then 200 says that it was created. That's the specific code for that. And then I don't implement patch, put, or delete. I don't really know what these should do. Perhaps some sort in the future, as I said, could be done by a patch. Put seems really strange to put. You actually send all the data again, so that's sending the full collection. I don't really know why you would want to do that. And delete a full collection, remove everything. That's a little bit harsh, I think. So that's the collection endpoint. And then we have the notes item here. And I can take a quick look at one of the helper function here. I will check if something is valid. I will check if it's a JSON object or if it has an ID, else I can't use it. So I will return either the 500 for not a valid object or 404. I could not find that current note. And then I have implementations for setting up the notes repository. I had those in the collection too. So the constructor of this collection or item will get a nodes repository when they are created, and then my get method will get one single node by ID. We can patch a node with this update node. Put updates a node as well, because there isn't any difference. You need to send the full data in order to do both these operations, so they don't differ. I could actually call one of them from the other, but I didn't do that. I just copy them. And delete is not much either. I will just check if I have it. If not, it will be an error code, and then I will delete it. And if that was successful, I will return 204. So this is the item and the collection implementation of the endpoint. So that's the back-end stuff. Now I wanted to create this simple HTTP server. And to do this with only Java classes, there is an HTTP server implementation inside of the ComSunNet HTTP server. So I thought that would be a great opportunity to use that, because that seems like the thing to do. And it was so easy to create this. You just set up a context and added your request handler to the path here, and then set an executor. I didn't want any executor, and then I started it. So that this 4 lines was everything I needed to start up a server. And the request handler was also quite simple. It implements an HTTP handler. I had my map of endpoints here. I set up some request handler to handle 2 nodes and nodes ID, and a function to get the request body. So this is just to fetch the data from the streams. I get a string back from the input stream, from the actual post or put and so on. And then I will actually create a response body here. So here I'll set all the different things that are required for a REST call in order to use Chrome's built-in fetch API, because that actually have some restriction that you can't do cross or origin calls and so on. So you actually need to say that you can access a specific allowed origin. So I set that to localhost 8081, and also credentials. I allowed those even though I don't do any credentials. I keep the connection live, and my content type is application JSON. I return a date and a vary origin. So these are all the things that a standard backend server will return with the call, and then I will just write the body and set the headers for the response code and the length, and also option pretty much the same, but it will not have any length, and I will have 204, which means no data, so it's content free. And here I also say that I allow get, post, patch, delete, and yeah, I set up this endpoint and I handle this endpoint here. Pretty much just create some implementation, have an options method here that handle if it's options, and the endpoint. I get the endpoint from the URI and then handle the request. And get this endpoint is very simple because I just wanted to get the first call to work, and then I could implement the rest of the get endpoint. But here is where I actually ran into a stone wall, and I couldn't implement this more than this, because the hard problem here is actually I tried to implement this by just overriding the HTTP endpoint, and that was not a solution. So let's see here. It should work fine if I just do T everywhere here. There is actually something strange with this implementation. So if we run this simple server here, and I think it should be doable. Could not find main class. Yeah, so now I have it running, and then we will open up add up my notes client here. So if I reload this and then check the actual endpoint here, I get a response back. Because the problem I got when I actually had the return headers here, that access control allow credentials and control allow origin, was with lowercase. And that was what I thought did this in, and that didn't allow this. It seems that something has changed here, so it actually works now. So my special little implementation might not be required, and that's fine. Things change. It haven't gone that many days since I did this implementation, so that's curious. But just to say here is that we had the problem of these coming back as lowercase, and one of the my little Chrome here couldn't take it. It didn't want it to be lowercase. It said no, I will not accept that. You must it must be uppercase or something like that, and there might be a problem still in some web browsers. I tried all the web browsers and got the same error in all of them. Yeah, but the thing here was that I couldn't get this to work with this implementation. I tried everything to get it to actually give me a response back, and it wouldn't take it. It was really stingy about that. So I had to figure something out here, and my solution was to implement it myself. So I actually have an implementation of a socket server, And there might be somewhere that you want to implement the socket server, and sometimes these headers might be required to be uppercase. So my socket server here is a little bit more involved, not that much. We have a socket server listening on 8080. We have a socket client that accepts a call, and this while loop will do an iteration while it's true. So you can actually have something here that tells it to shut down after a while or something, but this while loop will just go through and take the next call, the next call, and the next call. And you could handle this with many threads and so on, but I did a very simple solution here. Then I had an input and output handler, so the output stream is an output printer, a printer writer, and the input stream is a buffered reader. So I have those worked out here. Then I have this socket headers, so I read in all the headers here, and then I have a request handler, and I give the headers the in and out buffers, and then I flushed out buffer and close my client socket and then try again. The socket handler headers is quite simple as well. I will fetch the method, the path, and the headers. And to read in the method, I know that the method and path comes in the first line of the headers. So I will read the first part, which usually is get, post, delete, or anything. And then after the second space, after the first space, you have the path. So I will pick that. And after that, I think it's the HTTP version number. So if you want to pick that up, you can take that as well. And then for every other line after this first method line, if it's not empty, because that means that you have ended up after the headers and want to read the rest of the data, because you have two catch returns before you actually go into the data. So you have one catch return after the last header line and then one more to get to the data portion. So if I have an empty line, I know that this is the end of the headers. From now on, I want to read data. So I will look into the headers, look at the first column. So that's the name part of the header, and then the value is what comes after. I will separate these into key and value and put them into my headers map. And then I can get the method, the path, I can get the specific header key, and I can get the content length. So I've made a specific function to get the content length, and it will return 0 if that header is missing. Otherwise, it will return the actual length of the content that is received. And I haven't actually used any other header than the content length, so this is grayed out. And if we go into my socket request handler here, it's pretty much the same as we had before. I have this socket request handler with my endpoint map, the two endpoints, and then I have my request body getter, and this is a little bit more involved, that it actually fetches a buffer of array data and then appends that to a string in order to get all the bytes that are sent through the line until length is met. So whenever I hit the length of the stream, I will stop reading. No, actually, I just take the length to see if it's 0, then I will not read anything, and otherwise I will actually read all the data in the stream until there is no more data sent. That's interesting. And then I have my response body. It's just simple print lines on the output buffer. First off, I write the response code and a response message. So these are all standardized messages, and I actually implemented a class with all the methods, all the messages that could occur in the HTTP specification, and this is also available on my GitHub if you want to use that in your projects. And then I send these other header lines that we saw earlier with the right casing, so it should work, and a date and a content length, and then lastly I print the string with all the bytes from my call. An option doesn't have any data, it will return a 204, which means no content. I think that's it. 204, no content, yes. And then all the access control headers, so the browser knows what to do with my call. And now we come to this little black magic to get the endpoint, and this function is quite involved. I first have a pattern up here to find all the keys, and I said that a key can be anything between these curly braces and have any letters between A and Z, upper or lower case. So this first pattern here will look for keys, and I will look for my endpoint, so I will set that to null from the start, and then I will get the path of the first endpoint, and I will have a little key string here. So in the input path there could be multiple keys. You can have actually the node's ID, the user ID, and so on, depending on how long your path is. And then I will have this test path that I will look into, and my matcher will look at the path and see if it can find any matches in it. And then while it's found any matches, it will get the group of keys and add that substring of that key, so without the curly braces at the end, and it will replace that with this strange little thing here. So this actually says that I want to find anything between two slashes. So start with the first slash and then go to the next slash. So everything in between there I want to fetch. So in this key I will replace where this this key little template was with from here on until the next slash, take every byte. So I will replace that with this little regexp thing, and then I will do a new pattern matching on the full test path with the replacements up here. And if first off, this string is not null, so I will have an endpoint actually checked. Then I will run my string matcher, and if it matches, and if the group count, so the number of found groupings, is the same as my key size, so I've found the same amount of places with data as the number of keys I want to assign to these data places, then I will say that I have a match. So if I haven't found this, I will continue with the next path. Otherwise, I will say that my endpoint is this endpoint. So I will set the endpoint, and then I will go through the key array. So for the from 0 to the size of the keys, and then fetch the group with the ID of this plus 1. So the first group is the full string. The second group it's the first of the groupings. So I will fetch the first grouping, and then I will add a path param matching the key that I have in my array with the value of the grouping. So for instance, if you send in note/1, then I will get that 1 set to my note's ID. to match it up. So if we look at our template up here, notes are the first path, and then I have my template of ID here. So if I send in something like notes/1, then this will be matched, and this part will be matched by my regexp and will be put out as a grouping. So I will pick that one and add it to my my path param map with the key ID. So ID will be 1. So that's what the last part of that regexp thing is doing. So my endpoint will have my path params set. And then I will return my endpoint because I found it. And if I go through this for loop and don't find an endpoint, I will return this null value up here. I could have said null, but I actually just say that I will return the previous value set. And my handle function is very much similar than earlier. I have my options here that will handle that separately, because then I don't look at any endpoints. I just want to tell the browsers what the options are, what's allowed to be matched. Then I will fetch my endpoint. I will actually print my method and path because I wasn't really sure why I didn't get any endpoints. So these are my debugging information here. And then I will handle my request with the method, the request body that I get from my in data here. And the handle request will give me a string response back, which I will send to my response body. So if I start my socket server here, it should be running now. And if we go into my notes client, maybe we can let's get this down a bit so we can see the actual, see what happens here. Yeah, so it's not the best server in the world. It has an issue of actually being able to serve many keystrokes and so on, but it works most of the time. More than less. But it was just a thing that I wanted to try out in order to test this technology. So there it works again. So it doesn't respond every time, which is a hilarious side effect. But we see that data is actually sent to the server and saved. So it is there. We just have to make it more reliable and actually respond every time. I think it can be something to do with that I have many things running as once and so on, so it might not be that reliable by itself. An interesting thing that we can look into is actually if this other request handler here couldn't handle our response if we just replace one part, because as we know, the only thing that I have actually implemented a little bit more in detail is this endpoint getter. So let's go into, if you use the same structure, you can actually replace parts and probably get it to work even with this thing. So let's try and see if the simple server is better at serving than my own implementation. That would be really fun. So now it's actually giving us something back. Hello, let's test the simple server out and add one under note. This works better, question mark, and then reload, and it actually works. So the implementation by the Sun, ComSun, implementation, so the real Java implementation works better than my hacky solution, and that's nothing that is that mind-blowing, that I couldn't do it better than the Java guys. But it's interesting to see how these things work. So I think I have created an example how to build a REST API that works with my Notes client, and actually shown how to build it in multiple ways, and I hope that you have some more understanding what goes into a web REST server and the implementation behind it, what's needed in order to get the server client communication to work. I hope that you learned something from this video. I hope that you found this interesting. This is actually a part of a series where I wanted to go one step further so I can generate this server in some part. So that's going to be interesting. And if you like this episode, give it a like, share it with your friends and colleagues, and I really hope to see you in the next one.